record on this computer. All right, so we should be good. All right, good afternoon. We're going to be taking a look at checking a door unit today. I want this session to be interactive. So as you are as we're going through the explanation about our approach for checking a door unit, if you have questions that pop up, let's just address them as they show up. If you want to zoom into a particular detail or double check the math, or if something looks kind of odd and you want to point it out, just feel free to just pop in with that question as we're going. The point of this lesson is to go through the methods that we would use to check a door, and then to also point out we have some key takeaways that as we go through the session itself, we'll be pointing out a few particular items, but at the end we'll do a little summary. So we're going to start with the Culver Studios. I've already identified the unit from the key sheet. It's this unit 394 at the door. And I've highlighted on the shop drawings. So these are the set of tabs here. Okay, so somebody's got to mute. There, I got him. So then on the unit itself, this is how the unit came for checking for the first pass. So we're going to go through our normal checking process on here, where we'll take a look at all of the detail bubbles and the dimension strings. This is following the same checking format that we went over with the unit checking. So we'll go over these pretty quickly. All of the detail bubbles here, the two on 551, the one on 569, and the two on 569 at the door, the two on 551 over here. The head, the intermediate vertical, this one on 570, the one on 510 is the alternate detail at the head member. The three on 507 is the typical horizontal, the one on 507 up at the head. And then, we're missing a little something here. Since this is a door detail, in this case, we've got a TO5 and a TO6. Take a quick look at those. And that shows that we have a curb condition. And then on the TO6, the next page, that's the opposite side of the curb. So with that in mind, 209 was my other shop drawing set. This is 202. With that in mind, since we have a transition here, we want to go ahead and call those out. So we would add in the one on TO5 here and the one on TO6 on this side. This also gives that good visual reference for the shop when they go to this area and they can see what the intention is. Now with the normal unit checking process, we're also going to identify all of the dimension strings, make sure that those are all correct. So I'm not going to do the math, but I have a little shortcut just for the demonstration purposes that I did check the math on all of these, and these are all correct. So I'm not even going to take the time to green them all out, but just keep in mind, dimensionally, these are all correct. We'll start then at the sill. We'll work our way from the bottom to the top and then from the left to the right, the same way that we would with a normal unit. A few things to keep in mind as we're starting this check is...
Bill?
Yes.
Sorry to stop you, but there's no dimension showing how far from the bottom of the horizontal to the bottom of the transition detail. So it's missing a dimension there. It should show how far that is down to the floor or to the bottom of the vertical.
So this dimension right here. Is that the one you're talking about, Ron? Right there?
Yes.
Yeah.
Okay.
Oh,
Very good. The other things to point out is that when you're looking at a door unit, sometimes the unit that is adjacent to the door is going to have an effect on the fabrication on some of the parts of the door unit. So you have to keep that in mind as you're going through the process of checking the door. You may need to look, in addition to the door unit itself, you might have to look at its neighbor in order to determine what happens with some of your cut lengths, face stops. Maybe you've got an end cap condition where this door vertical runs through. So all of those are factors. Now, in this case, if we're just looking at, let me look at my notes here. So the typical sill, if we're looking at that one, it's the 503 detail. It's the strip window sill. It should have a notch at a captured condition. Go back to our elevation. And on the vertical cuts, we've got the 2 on 551, which is a captured vert, and then the 569, 5.69 on the other side. And that's the door, and it's a captured door. So I'm expecting that this horizontal is going to have the notch on both sides of it, and the daylight of the 23 1/8. So I would mark this one green and then continue from there. So in this case, the left and the right horizontals are the same. So they do have the same mark number. Those are both correct. So as I mark up the fab tickets, I would also mark that up on the unit assembly drawing. Next up, the face stop down at the sill. In this case, I've got my daylight as the 23 1/8, and then at the door condition, I'm going to have the -1/16 here, and then on the right side, the typical intermediate vertical, the 5.51. Oops, keep hitting 0 instead of my decimal place. Then that's going to be tight on that side. So I'm expecting that this is going to be 23 1/16 on my FS1-11. And that's the cut size that I get there. I would mark that green after verifying the part number. So I'm shortcutting through some of these things. The basics we kind of know about a lot of how that works. When I go up to the next one, the horizontal here, the HZ1-18C, my total size at the 125 1/4, I can verify that based on the dimensions that I've double checked here. So when I add all these up, the cut length is going to be correct. Now, one of the techniques that I'll frequently use when looking at this type of a unit, it's going to be a little tricky with examining through the shop drawings since I'm just using this one screen. But this is what I'll do frequently is in fact, let me close this for a second. I'll actually split this to where I have the unit assembly drawing here and here, so I can keep this open and reference the unit assembly drawing, especially if I've verified all of my dimensional strings. That helps give me some good reference for when I'm doing this checking part on the horizontal, because I can open the horizontal here and I still know the content. Where is this horizontal occurring on the unit? So as I'm going through, I will have double checked the part number, the size, etc. Then when I go to my layout here, you see that I have clips on the bottom and on the top. So if I'm looking at my math, I've got my 23 1/8 daylight plus the width of the mullion, 2 3/4. My 25 7/8 would be correct. I'm not going to go through and click through to these clips. There are a bunch of different versions, but basically the clip fab is all the same. The different versions are because they're placed differently on the head member. So that's one of the things that you'll see as you're checking these. This checking copy, I didn't drag all of these clips into this folder, so they're not all in the checking folder. But as you're going through these, you'll see that there's a bunch of different clips but in practical terms, these are all the same size. They have all the same hole layout. When I go to the next one, this is the intermediate at the top. I've got the 61¼ daylight plus the 2 3/4. That gives me 64 inches. Keep in mind that the dimension points that are shown here, we've got a datum point, and then we've got the offset for where the clip is, and we've got how wide the vertical mullions are. So in this case, I've got that, it's not really showing that 2 3/4. So I probably want to indicate that there because it's a little different than what I'm seeing on those other two. So if you see some inconsistencies in how your fab looks and how it's working, that's something that you should mark up so that you get that consistent look on your templates as well. Because I'm seeing them here, but I'm not seeing in that intermediate one. So I'm good with these, and this is okay, but I want to add that, so I put that in there. And my 64 dimension is correct. Now, when I go to this one, my 61¼ I'm sorry, the right side, I would have my 125¼ minus my 23 1/8 daylight would take me to the right side of this lower vertical mullion. That's where this clip is going to be. Well, when I do that math, it doesn't come up with this 100 3/4 dimension. That dimension is actually 102 1/8. So I'll need to mark that up as well. Now, if you have this situation where you have both these clips are indicating that that's this vertical, you don't necessarily need to write this dimension down twice. I'm just indicating that this is the dimension that's where that vertical member needs to be instead of this 100 3/4. Then I'll just double check to make sure that the placement of the clips is correct. Now I've got something a little weird here. I've got a 15/32 on one version and a 1/2 inch on the other, and then I've got a 5/8 from the back. So I'd probably want to go in and look at these to see why am I getting a 30-second different dimension from the top clip to the bottom. These are the same extrusions above and below on the vertical mullions. So one of these is incorrect. So if you need to, you can go to the CAD drawing and measure which one's correct. And I didn't do that. I don't remember what the markup was on this. Eric, do you know which one of these dimensions is actually correct?
I'm at the one on the side.
The 15/32 from the face to the face of the clip compared to this one showing a 1/2 inch.
I believe the 1/2 inch is the correct one.
So we'll verify that, but in this case, you would not have two different dimensions for that clip when it's attaching to that vertical. So there's some kind of a typo going on there. Okay, once we complete this, since we had some markups that happened on here, we're gonna mark that one red. Next up is gonna be this horizontal face stop. In a double wide unit, which is the typical way to approach when you have a pair of doors that span across two units, even if it's this big, it's over 10 feet, it's over 10 feet wide now, but the field prefers to be able to install these as one unit. And now we have two pieces of glass above this horizontal member. Well, if you have two pieces of glass, you need to split this into two face stops. Right now, this FS 5-11, that's running just as a single piece. But the problem with that is that if you need to get in to reglaze this, you don't want to have to take off two separate face stops. The logic of how this would work is you would follow the same logic of how your split would work if you had the vertical running through. Now, even though the horizontal runs through and the vertical sits on top, let's take a look at the shop drawing detail for that 570. and you have the 16th inch gap occurs on the right side of that vertical mullion. In this case, the way that would look is you would have your face stop would run to here, and then the other part of that face stop would run and have that 16th gap. And of course, this is exaggerated just for demonstration, but your gap would be on this side of it. With that in mind, this FS5-11 doesn't work as a single piece running through. It needs to be split.
Question, Bill.
Yes.
So we're splitting it there. What if we're working with deglazing and glazing this one? Would we want to split that into another piece? Same thing out here. If we're only working on this glass, would we want to follow that same concept?
So the key for this is that you need to have the removable stop in order to replace this glass. So here, the removable stop is this one. Here, the removable stop is this one. This doesn't have to be removable to put this piece of glass in. This one does. This piece of...
Yeah, on the top one, you just have to take the gasket out.
So...
On the top part of that, you would just remove the gasket to get the glass in, and then remove the trim on the bottom, then we put the gasket on top and bottom.
Yes.
Bill, is there any way we can remove this gap? I don't think this is good. I mean, visually.
So that's not part of this lesson, so I'm not going to address that, but the detail is showing it with that 16th gap. That's the logic of the system. So that's the way that that is built. That's the way that we do the fabrication on it.
That's fair. I'm bringing this one back.
That's the way that we design this system. It does need that 16th inch gap in order to match the visual of the rest of the curtain wall as well. So that's why we incorporate it that way.
Thanks, Bill.
As far as I remember, we would have done this in one piece, especially that is right above the door, and you know, visually it's gonna be something that is gonna be right there as soon as you get and approach that door.
Yeah.
So that's why we want to have this training session, because that was how it was approached when it was built, but that's not the way that we should approach it. That's not the correct logic. So it might make sense that, yes, one piece running through would look better, but that's not the way that our system design is set up to work. It's designed so that you can do that replacement part, and it matches the design of the rest of the curtain wall.
Hey, Bill, I have something on that too. Is that detail 1570 used in the joint unit? Because if it's not joint unit, even if it's shown there, I might eliminate that 116. It could be tight joint just for the vision.
Because there is no movement there, Bill. There is no contraction or expansion.
You don't install that separately, Mario. It's one unit.
Copy it here, modify from here without thinking. I don't think this is purposely put over there. That's just my opinion. But Bill, I want to know if we able to make this straight, no joint over there, is that preventing or creating difficulty for us in the shop and field?
In the field, yes. This would be a difficult condition if you had to replace this piece of glass, either of these. You wouldn't want to have to remove that entire face stop in order to replace the piece of glass.
Got it.
Yeah, that's why if it's a one unit, it's still two piece, but it's a tight joint. Because the 116, the logic of the 116 joint is for a 2 units. When you install the other unit, you need that 116 there, or for the kind of gasket that you have there.
Okay, sorry, interrupt. I will bring this one to another things to talk about it. Thank you.
So those are all good points. However, the logic that we've been using is following what's showing on that detail, including the 16th gap. Yeah. If we want to make that as an improvement, then we need to run it through its paces, right? Yeah. Send that question to the Standards League. Hey, we normally do it like this with a 16th inch gap. Can we make an improvement and tighten that up to where it's no gap.
Yeah, and even then, offset to the right side, even hard splice or a 16th, it just looks like a mistake too, being off to the right instead of center, to me. So I
Yeah,
always
it's
thought
only
they were
one
one
side,
piece
it's always
also, one
116.
piece. But
Exactly. That's kind of a patch piece looks like.
Even unit to unit, 116, one side only of the unit. Yeah.
Well, you also have a problem on the one on the left. If that cap on the vertical above it is hard down to the same level, how do you rock that cap off? If
Yeah,
that vertical cover, so you'd have to hold a 16th on the vertical cover above so that you can actually get the cap on the left side off of the vertical, I mean on the horizontal, to remove the glass.
Can I just weigh in real quick here? I just want to mention how much I love a team that can talk about this 1/16th gap at this level. I just love you guys. Like, worried about it, looking at it, questioning it. I just love it. Like, no PM would ever think twice. You know, like everybody else would be like, whatever. But we're literally going deep. I thank you very much.
they would notice it when they were out at the job going, why did we offset those? Or why did we do this?
Yeah.
Well, we should have asked you, I guess, first and said, this is what we're doing or whatever, right? But that's really when they had noticed it.
Yeah.
And
No,
they-
I think we've been burned enough in the past to know that we got to dig this deep. So
love it.
So if I was actually going to do these mathematically, then this FS5-11 actually becomes two different sizes. So I'd have a left and a right, where there'd be an 11 and 11X. So my cut sizes would actually be 63 and 15/16 and 61 and 3/16 would be my two sizes. And I would indicate that on this fab as well, so that when the PE went in to do these updates, they'd know which one was which. In fact, I might even just leave this sketch on there to make it clear which direction these are going to run.
Yeah, and I just want to make a comment here. The way Bill does it here, like indicating on the unit assembly drawing to break into two pieces, giving the two different cut sizes, is perfect. It's really clear, and there's no question about it. On the this is, I would think this is the preferred way to mark things up, especially if you have a new part introduced and new piece introduced into a unit.
And my actual markup on that has a little bit more words. It says split into two, left side is this, right side is that. But again, just because we're doing a demonstration, this gives you the idea of how that would look as you're doing the work.
Yeah, I agree. As a person updating, I sometimes come across, hey, split this facestock in two, and I'm like, okay, I can split it to two, but now should I get it rechecked just to make sure that the cut size is correct, right? But having that is totally good. Yeah, I agree.
Yeah, if you're doing this, you should put the cut size, because let's say Jose did this and his cut size would be 63 and 15/16 and 61 1/4. And then I marked up the other unit, which is identical, except it's this different glass type, different door number. And then I've got it listed this way. Then you come back with that question. Hey, Bill, Jose, you guys are not making the same logic. What's real here? Then you have that conversation of what you really need it to be. And then if it needs to go to that next level, you bring in the PM, the field guy, whoever is going to have a vested interest in where is that 16th gap needed, or do we eliminate it altogether? Next up, let me see where that one was. So next up is the head member, the HM1-18D. So in this case, the math was good, the 125 1/4, the part number is correct. And then as I'm going to look at what's happening with all of the prep here as well. So we have, there's a -1/16 notch on both ends of this at this 6 7/16 dimension. And let's see why we would do that. Take a quick look at our elevation. I'm sorry, 209 is the sheet I was working on earlier today. So our head is this one on 507. the head member is a closed head here, but then it's got an applied face stop. So let's think about the face stop here. You need to be able to get the face stop and our normal condition here, you'd have a little notch if you had a captured head that had the built-in face stop. You'd have that little 30-second on both sides in order to be able to put your vertical trim on. So we've got that similar type of notch happening here on the head member. Now, I'm seeing also, let's change gears for just a second. This face stop that's running here, this FS3-11, that's also just running as a full-size piece, and it's 1/16 smaller. So that would also have the 1/32 deduction from both sides in order to allow your vertical trim to run through. Now, why is it okay to run, or is it okay to run this head member as a single piece compared to that one that we just spent 10 minutes discussing, this 1/16 of an inch? But this one's also running through, and I'll tell you, I marked that green. So why would I have marked that one green instead of worrying about that when I didn't worry about it here? So why am I letting this one run through when I split this one? And it's very intentional for me.
Is it the same reason why Ron mentioned earlier, that once you take off the face stop at the bottom, you'll be able to deglaze and do everything without having to take off the face stop at the top?
Yes. So you don't need to take this face stop off in order to reglaze this. But there's a second level here too.
I think it should be all the way to the right and 16th gap on the left-hand side. That's our typical for those covers, because when you fit the other unit in, you want to have that same consistent gap at the left jam of this unit per that detail. If you look
Agreed.
at 551, 2 on 551, that joint's on the left side. So the right side, it's tight up against the vertical.
Yes, your face stop is going to have that, the head member is going to have that deduction on both sides that allows you to put that piece on. But you're right, Ron. In the shop, this vertical trim to make this captured is applied here. Their practice is to butt this tight, so they will butt that tight, and it'll have that 16th gap on this side. But the secondary reason that I would not cut this, even though here, you know, we talked about visually, this is what the rest of the system looks like. This is going to be that 16th gap. But here, if you have a captured head member, in a lot of cases, we don't have the captured head that has this removable head stop. It's a full face. You have that 30-second gap on both sides automatically. So if that's the case, you have the 1/32 gap here and here. This head member, if it wasn't this applied stop, would run through. And for that secondary reason, you don't have to take the face stop off to reglaze it. There's no reason to cut this one down. It's going to look the same as if we had this building across the street that had the other system head instead of this one with the removable head stop. Okay. So just a couple additional points here. I would make sure that the notches for this work. Now here's a key point. We have our normal head template pops up with these. This is a strip window head, so it's got the Mini-Mac cutout. Well, this is the double wide unit. You can't just leave one clip on both sides, which is our default. And you can see that we did add this secondary cutout in here, and it's dimensioned. So this is a different set of steps to create this secondary Mini-Mac cutout compared to what the typical template's going to have, where it's just got this on both ends with this default dimension. So this is actually correct, and you would want to verify these layouts in the same way, so that if you're at this 3 1/4 from the end of the head to the end of this cutout, you would have a similar math occurring here and here. Okay, The other one is that this is showing the datum point for this intermediate vertical, and then you've got your clip layout, so you're showing the actual pilot holes that are going to be installed here. And then as we look over this node, it tells you to put the holes in. There's a little something weird here. The note is calling out for using a tube as reference. So that's telling me that this was copied over from the pony tube note instead of the actual vertical. So I'd want to mark that up because this copy of that note is not applicable in this case. Plus visually, you see that this thing is offset. It's not lined up with the glass pocket the way it should be. So I would probably also point that out, okay? So that gives us a lot of the horizontal stuff that's happening.
I just want to point something out here, real quick, Bill. I just noticed it just now. If you zoom in there, if you just take a look at how the notching is placed for the one in the clip.
Yeah, I was just going to say the same thing.
It's placed in the wrong spot. Either the final fab or the release version was just kind of moved incorrectly, or the AP picture is wrong. So these are
And they shouldn't be dashed.
Yes.
Oh.
And there
It
is
should be a solid. It's a solid hole on the top of the part. It shouldn't be dashed. Just should be look just like the one next to it, to the left.
Wouldn't the two different dimension sizes flag anything?
Which one?
Well, they're both the same, aren't they?
Yeah, they are.
16s.
The
They
size
should be the
of the
same.
dimension.
They're just not located in the right spot.
It's just, you see how the vertical is pushed past the back of the mullion by a little bit?
Yep.
So
Yeah, it just moved.
Yeah, the setup was set up wrong there. They just need to move forward.
It just moved.
Can I say something? Sorry.
maybe.
I would personally think it would be maybe a good idea to combine those two notches with the central one, with the one with the two holes, and have it as a one attachment. I'm just saying, it would be easy to manage it.
Oh, you mean have one central one and then have it from the left?
All those three
right?
pictures on it, yeah.
That
Because it's always related to the central one.
So
That's what
you're
we're
saying
doing.
tie these together?
Yeah.
As one big one, you mean?
No, this and then the one on the right. Yeah. Yeah.
So you're doing one big notch instead of two small notches? Is that what you're talking about, Yana?
No. It
No,
would look the same. It would look the same. It would be just in one attachment picture, kind of.
Yeah.
Oh, I think I see what
One
you're saying.
picture to show this and these two notches. And that does make sense because the relationship of these notches would have this 3 1/4 inch dimension as well. So
Yeah. I'll look into that one. That's a pretty good suggestion.
So the other thing is the notch that is shown with dash line, it has a datum. However, what I will say is, from the side of the intermediate vertical, we should do the same as the other sides, which is 3 1/4 inches from that side. And what is happening here, I believe, is that those notches shown as with dash line and the detail that is showing the location of the verticals with those angles, it was copied from something else and it was inserted not exactly in the right position. That's why in the holes, they seem to be offset.
Yep. So this is what Mario and Yana were kind of referencing. Is it would look like that instead.
Exactly.
Yeah. And then you can use just that one data point here and tie it all together.
Mm-hmm.
Okay, excellent. Now back on the, so basically that takes care of this stuff horizontally. The next thing we would do is look at the vertical things that are happening here. And I'm running a little long, but that's fine. I want to start looking at, let me scroll down to here. So this is just a typical vertical. If we looked at the shop drawing details here, we would see that this sill member doesn't have an effect on this normal vertical. So basically this one has the strip window notch. It's got the horizontal height laid out correct. So this is really just green here. So I'm just going to mark that one. good. And this is where we start to get into some of the things that are key for the door unit itself. As we start to get into these verticals where it's got the door on this side, and then it's got the door to the door adjacent over here. Let me see which unit I want to do. One second here, the SV1 56A. This is the next one I want to look at. And let's keep this open so we can see. This is the male vertical on this side. In this case, when we look at what happens on the shop drawings on this elevation, we have this one on TO5 is the transition. The transition details and the curb details that are calling out here, those are done by Esley's team so that the logic of how we're approaching these conditions stays consistent. But these conditions may not be the exact parts that are on your project. They may vary from project to project. So as we're going to this one on TO5 here, we're going to take a look and we're going to read through what some of the logic is doing here so we could see how is this supposed to work. If we look at the first part of this, the sill track is notched to fit the mullion as shown in this detail B. So we're seeing that the sill track is notched inside of the vertical mullion. So that's going to have an effect on this male vertical. What are we doing with that? Well, the sill track runs underneath of it. So we'll keep that in mind as we're starting to look at our fabrication. Then it says notch the stub mullion at the bottom to clear the angle clip. So this stub mullion down here is this guy, this number 2, and it's short and it runs underneath of that sill and it's got this giant notch in it to go over the top of this clip. So we're going to keep that in mind as we're looking at the fab on this little stub mullion as well. Then it's got attached the stub mullion with the W75-56-46 clip. Well, that clip kind of has a default 2-inch length on it. So we're going to keep that in mind as well when we look at this, the total length of this little stub mullion. And then it's got plugging with sealant, etc., and the field install. When we go back to the elevation, keeping in mind what we just saw there, this vertical, the male vert, is going to have the regular strip window notch at the bottom because it sits on top of the sill track. When you get over to the next mullion over, this one runs beyond that, and then it's got an angle clip which is attached down at the curb. So when I look at the detail at the door, I've got the angle clip here which drops down and it's attached with a concrete anchor. Then my vertical is notched to clear that mullion. Let's take a look at what that looks like on the actual unit assembly drawing now on our fabs. On my vertical mullion here, the SV156A, keep in mind that's the male vertical. It's got the normal strip window sill here. That's correct. Then we've got these 3 sets of notches here that are going to attach with that W75-56-46 clip. When you have the vertical mullion at a door, these two get basically bolted together in order to create that door unit. That's what these notches are for. The top of this is also notched because you have this. We already looked at this when we checked that head member. This has that 56-46 clip running down into this cavity. So we've got to notch the top of this vertical out in order for that clip to fit inside of there. So if you were to have this fab open, that clip has to run through that area. Well, now we have to notch that area out. That's why, you know, this clip is going to fit inside of there. So we've got that notch at the top. That similar notch is going to allow that clip to attach. Let's go back to the detail for a second. It's going to allow that clip to go through here. Now, one of the things that we've been doing is when we have this clip, the detail that's currently in the library shows this always attached to the female vert and the notch is in the male vert. What we've been doing is flipping that over on this side. We want to keep this clip as pointing away from the glass. When this clip is going in this direction, this screw right underneath the glass, the shop has difficulty with that. So they've asked us to flip this over. So we've been flipping this clip, pointing it this way, and then putting this countersink on this side instead. That way the shop has access to be able to get in here and put that screw in by having this pre-attached on this side. So the setup team is going to be fleshing out these as sketches and sending them to the Standards League so we can actually start incorporating this switch into the shop drawing details. Now.
So Bill?
Yes.
In that case, then it's important to note, can you go back to that detail you were just looking at, or the one that showed the 5646 clip? So if you do swap that 5646 so it goes the other way so you can get that screw in, then that affects the sequence of when that 90-221 angle can go on, the one that closes off the glass pocket.
Correct. We would still show that on the fab for this vertical, but we would not show it bed and sealant because the shop would need to be able to remove that, put that in with this flathead underneath of here, and then apply this afterwards. So that's why on the door details with the pocket filler, you don't see the note bed and sealant.
So Bill, what I say over here, because sorry, I always talking about probably not related to this one, but I try to get feedback from your team. So what I hear, you actually this detail not reflect what we're really doing right now. Flipped, I understand, always attach accessory piece to the male side because the male side always in there first before your next unit engage into that one. So it makes sense. So does this detail, did you tell our team this is not actually reflect what we are doing right now? Or anyone report this already or no?
Yes, and we're also going to be creating these sketches and sending them to the Standards League so that once we get the definition of what we want it to look like, that it will be developed through the normal channels so that all of the families and the details can be updated accordingly. So that is in the works.
Thank you.
So for this condition, you see that this is actually notched on this side, the same, let me see if I could bring that detail back up again for a second. So this was fabricated based on how this was detailed. In this case, we did not switch this. However, I might mark this up in order to reflect the current logic that we've been using. And then these, instead of having the notch here, would actually have the clip showing up there.
Right. And the main reason, in my opinion, is because also, can you go back to the detail? Okay, in this case, the unit containing the angle, let's say, or the member containing the angle is the female piece, which goes into this side of the door. But if we do this, there is no way that we can put that screw because this unit is going to contain the glass already. So.
Yep. That's why we flip it over.
You'd have to leave
Yeah.
the glass out first.
Mm-hmm.
Yep. So this one was fabricated according to the detail, but I would probably mark this up to put the clip on there instead.
Okay, yes.
And I'd be more detailed, but that's just to give an idea that we would have a markup to show that. I would actually probably put the markups on the clip mark number, etc. Okay, so now back to I would verify that these notches worked, the depth of the hole worked, and this still attached to this clip. Remember, this clip is going into this little cavity, so you want to make sure that that screw catches that clip. So we want to verify that that 1 inch down will still hit that angle clip and not, miss it. And it does. This is the standard notch, 1 3/4 down, and then the 1 inch for where the hole goes. So the notching parts look pretty normal, but again, we wanted to flip that over compared to how the our practice logic is based on the feedback from the shop. So let's go back and look at the SV256B. So this is the other vertical mullion. In this case, the glass will be here, and this is pointing away from the glass.
Yes.
So this is correct. And as I look these over, I'm actually seeing something pretty weird here. I've got both the clip and the cutout for the notch. So that's, I don't want both, right? So I'm actually going to mark these up to remove that extra notch in there to where it would only have the cutout for the clip. So I'm going to skim past some of this because I'm running out of time and there's a couple points I need to make. The other part of these that I wanted to look at is these little verticals. The SV222E. This is the vertical that runs past. So now this vertical is running all the way down, and we looked at the detail. If you recall, this has the curb condition, and at the curb, this has to have the notch for, let me bring that shop drawing detail back up. It has to have the notch for this big angle. So we need to clear all of this out of here. And if I only look at the fab and say I have a notch for the door at the bottom here, that's incorrect. This notch is for the door that sits on top of a sill track, which has a very small angle in the front, which is why this notch is only limited to these front portions. This ISO here shows it's only that front portion. However, that doesn't really work. This needs to notch all the way out of here in order to accommodate this angle. So that's a key point, is you may have a notch on a door notch on the bottom of your door, but you have to look at what actually happens there to make sure that the notch at the bottom of the door unit works for how the door unit needs to anchor. This is not the correct notch. When we look at the actual finished version, this is that notch. That's a 2-inch notch and goes all the way through. That clears that big angle. So this is the curb type notch when you have that anchor at the curb. This is the notch for a sill track. So we have applied the wrong notch on this template. So just keep those in mind as you're doing that. The other part that I want to look at is there's a little vertical that runs underneath. In this case, we saw on that transition detail on the TO5 that little tiny scab-on piece here, and it's got this giant notch. So that piece is the SV1-1F. So my part's only 3 inches tall. Mathematically, I have a 3-inch curb. This one is laid out so that it's tight to the bottom of the sill track. When I look at my detail at the sill, this is laid out. It's a 3-inch curb, and it needs to come 3/4 of an inch above the finished floor to the bottom of that vertical. And then that makes it to where it runs tight to the bottom of the sill track. This logic may be subject to change. We may not always be running these tight. The door perimeter Kaizen this week, we were just talking about this may hold down 3/4 for the field installation of these conditions. So that's part of it. The second part of it is we may not do these little stub verticals if that curb is less than 6 inches. That hasn't been finalized yet. Part of the key points here is that the door logic may be subject to change. So we need to continue to have conversations about how these things are working. In this case, because this was built with that transition detail, we fabricated it that way. It worked, it's installed, there's no problem with it. But you have a 3-inch vertical and it's got this giant 2-inch notch. That only leaves you 1 inch of material here. And if we were going to try to put that clip, as it's called out on the shop drawing detail on this T05, it's calling for this W75-5646 clip in there, in this area, it won't fit because this thing is too short and that you'd be removing all your material. So we experimented, we made a few phone calls, and basically we decided this little portion that's left here is big enough to be able to put the coupler in there. So we used the coupler the same way that we would if you had the vision area of a unit that's bolted together. And that allowed us to attach this small piece of stub vertical onto here without having to do that notch. This is attached in the shop. It's part of this unit assembly. These are bolted together. Now it's not called out here, so I'm going to put the markup on here to show bolted vertical. That would attach these.
I have a question, Bill. For this one, why would we split that male vertical into two? I feel that that transition is more for when you have two units, and that stub should be on the unit that's coming in after. The curve here is within the same unit. Couldn't we just run both verticals all the way down as one pieces? Both?
The reason that that's done in this particular case is to do the sealant work. That sill member is notched to fit inside of this cavity so that you can do the sealant work for the end of the sill track. The other condition that we won't have time to go to, but the way that they did it on vans is more like you're describing, Pedro, where the sill track is held 1/4 of an inch over here, and then both verticals run through.
How would they seal inside that, where that 1/4 inch dimension when the unit is installed?
You do these foam plugs at the tops and the bottoms.
So you don't necessarily
It's
seal
blind.
the sill
Yeah.
track, right? It's
It's
more
a
the
blind
vert.
seal.
It is blind seal.
It's a blind seal.
On the other vertical, you have to notch the male legs too on the other side to clear the sill track, at least the front one.
Correct. So here, when you have this sill member that's notched inside and you've got this male vertical, Ron makes a great point here. This also happens when you have the transition where you've got the sill track running into this cavity. This allows you to close this off and do your sealant work. However, you have to notch this male leg in order for that sill track to run over that far. So those are some of the things. Like this one, we would have seen that here. If we would have had time, we would have noted that this vertical would have needed that little notch as well.
Yes.
So there's a lot of things happening, and I had intended to run into the van so that we could do Pedro's point as well, where There's another way that this is detailed where the sill track is actually held 1.25 inches away from the daylight of this so that you can run these verts through and install these units as a whole with both verticals running through. That's how Vans is set up with a 2-inch curb. Now, we may get to a point where we fine tune what these are doing and have a consistent approach to them. For now, just be aware that the door logic may be different than what you're seeing on a normal unit. It's important to take a look at your adjacent unit so that you know what's happening there, okay? So we have a few key points. I'll just point out a couple, and then Eric has a couple as well. So on the double wide units, this horizontal needs to split so that you don't run it as a single piece. We already talked about you need to look at the adjacent units. Some of the door logic may be updated on the fab tickets, but it may not be shown on the details yet. So for example, this one where if we had that clip flipped over, and if you have that and something looks different on your fab compared to what you're actually seeing on the shop drawings, ask those questions, bring those things up. Why are we building it this way when the detail is clearly showing that it's doing this? And then some of your hole spacings may have been updated as well. So we have like the 2 holes here. The current version, we have 4 holes attaching to that clip at the bottom. And then Eric, did you want to point out your 2? I do have that document that you had.
I have it open too. But to kind of just following up on what you just said about the holes, right? So that kind of goes into like our standard is constantly kind of either improving or changing, right? So we're in a transition, you know, within drafting to implement those changes, or like, you know, we won't implement them. So if you ever have a question, you should just ask, you know, right? So you may, what I'm trying to get at is like you will maybe see your detail one way, and then if you pull up on like the standard library, it may be a different way. So just, you know, if you have any questions, just ask and say, oh, do we need to go this route or that route? Or so for me, it's like it wasn't really clear on where the line was drawn for the 4 hole, but it was just it wasn't clear for drafting either. So I just want to make that point. And then the second point is just the door threshold tag that comes in automatically from Revit. It would require some kind of manual work from for our team. I made a guide, but because we finally just established a consistent way to model the door verticals, I need to go back and update the little guide on how to name the threshold tag, how to name the threshold tags. So I haven't put that up anywhere yet. I've given it to a few to test it out. Seems like it works, but it's just missing some key points like when to deal with like split vertical jams at doors, because we're seeing more and more of those.
Okay, we're out of time, so not a lot of room for questions unless somebody's got just a quick one. I know we did field questions as we go, and thank you for participating in that way. Appreciate it for everybody.
Bill, just one quick question. You mentioned that you're in discussions to finalize what is the logic on either the seal goes in or stays short, or, you know, with the scaled down units. When do you think that you're going to have a final outcome of that?
We haven't put any projection on those target dates yet. Okay. This is something that we just started looking at in our door perimeter Kaizen, just popped up this week, that they may be developing a more consistent approach, like the 6-inch curb, for example. You may have a flag unit there instead of that stub vertical attached, but that hasn't been finalized. It's just in the initial discussions.
Yeah, because those would need need buy-ins from the field, right? So we need like information from them before establishing that. But then from when I dug a little deeper into the engineering meeting that we had 2 years ago, one of our meetings was talking about what Bill just mentioned, the 6-inch minimum. Anything 6-inch or more would require a scabbed in piece. Anything 6-inch and below can be flagged. But I think we're operating with the assumption that no one likes flag units. So no matter how tall the curve is, we try to always flag it, which is, I mean, not flag it the other way. We always try to add a scabbed vertical, which is kind of ridiculous because as you can see, or a job we have right now is the one west side, we have like 1 inch curves. So.
As soon as you have probably a final product or final decision, you know, if we can have another meeting like this or training meeting like this, but those kind of conditions are happening in every project, practically in every project right now. And more times than none, they become a problem.
Yeah, and that kind of goes back to like everyone need to be a little proactive and talk to their field superintendent and say, hey, I noticed that this curve is so small, can we flag the unit, right? It's one thing to go back to having someone set the standard, but you know, if you look at it, if it doesn't look right for your job, just talk to your food superintendent and then establish that rule for your job specifically, right? It's not a problem.
Okay. Well,
All right. Thanks for participating, everyone.
Thank you, Bill. Thank you, Eric.
guys.
Thank you.
Thanks, Bill. Thanks, Eric.
Thank you, guys.
Thanks, you guys.
See ya.
Thanks, Bill, Eric.
Thank you, guys.